All right, so in the project, you're going to have a figure similar to this. Now, I changed the numbers in it, so you would have to do a little work on your own, okay? What is a true statement about the measure of angle DCJ that's marked R degrees on the diagram? Okay, so let's take a look. What is true about DCJ? And they told us where it was. It's DCJ. What do we know? We know AG and CG are parallel. So I know I can come through here. Whoops. And so this should have something to do with our angle pairs because that's the lesson it's in, but we shall see. Okay, so these lines, these two lines are parallel. Notice we also have a line running through there, a transversal. Okay, here's our angle R. If you can, you want to just ignore everything on the inside here. So what I'm going to do, or what I like to do, is just cover it up. I wish I had something that does an outline. Okay, so all of this other information right now is not important to me because I'm just looking at the two things they gave me, which was that this pair of lines, is parallel, and I want to know what angle R has to do with any other angle. Notice they are a pair of corresponding angles. Well, hopefully you took a look through your notes and you looked back at what we've done in this lesson and you found out I know corresponding angles are congruent. So what do I know about angle R? I know that R is 48 degrees because it corresponds to the 48-degree angle, and corresponding angles are congruent. Okay, in the same diagram of the staircase, what would be the value of N? Okay, well, this one we're going to take a little different approach to. Okay, we're going to look at the other set of information we were given, that AD and FJ are parallel lines. So let me mark that on the figure. And again, if anything else that they give you that is written down, we really don't care about. We only care about the things that are involved with our AD and our FJ. Now, looking at our angle they're talking about, I imagine that this line here is also going to be important because it lies along our angle they're asking about, lies on that line CH. So if once again, I'm going to fill in any information, this 26-degree angle isn't on that line, but it does have an arrow pointing here also telling me that that is also 26. So I'm going to put a 26 here. And then I'm going to cover up, or actually I'm just going to make it neater, I'm going to color, hopefully neater, color over the top of all of that stuff that right now is not important. Okay, so all of these extra lines, not important. I just need the line that I'm working on, the pair of parallel lines, and the line that my angle was on. So this angle here is 2n plus 8. Notice this angle up here was kind of split into two pieces. I noticed that it's in between. They're both in between the parallel lines, so they're interior. The angle I'm asked about is on the opposite side of the transversal from this angle here. I want to total this angle. It's an 86-degree angle and a 26-degree angle put together. So I'm going to go ahead and put those together. And when I do that, I get that this is 112. Okay. Now, if I look at this picture a little more simply without all of that junk in there, this is the picture that I have. I have a set of parallel lines. I have a transversal going through it. I know that this angle is 112, and I'm trying to find the value of n for this angle that's 2n plus 8. Now we know these are alternate interior angles, and we know alternate interior angles are congruent. So I can set 2n plus 8 should equal 112. And now if I solve that, I will know my value of n. I need to get n by itself. It was added a plus 8, so I do the opposite and subtract 8 from both sides. When I do that, I get 2n is 104. And finally, divide both sides by 2. And I get that n in this case would be 52. Okay, so I took the important information, I brought it over here so it was less messy, easier to take a look at. I knew that I had interior angles, they're both between the parallel lines, and they were alternate on opposite sides, so they were equal. I used that to set up an equation, and then I solved. Okay, this is one of those optical illusions that people like to come up with to see if you are really seeing what you think you're seeing. So notice there's these sets of lines that are running through. Now, with those lines, they put hash marks on them. Okay. Now, without the hash marks, notice those lines with the hash marks, looked like they were crooked. They were running into one another. But notice as I draw over the top of them in another color, well, really kind of the best I can. I'll do that again so that we can see better. I'll use some straight lines. Notice what happens. Instead of them looking crooked, when that optical illusion of all those little tiny lines being everywhere, when that's taken away, or when you're focusing on something else, okay, if you focus on the blue instead of all of those black that's in there, these lines do actually look like they're parallel, but we've created an optical illusion with all of these little tiny lines going in opposite directions. They want to know what's a way that we can check, a scientific geometric way we can check to see if those lines are actually parallel or if that's just an optical illusion. Well, what do we know about parallel lines? Let me take them and carry them through. How could I tell if these two lines are parallel? What did we study in this lesson that allows me to do that? Well, notice the border here. The border is like a transversal for those lines. Okay, and if I check to make sure that my corresponding angles are congruent, so the angle between my line and the border, if those are congruent, I automatically know that these lines are parallel. So if I measure the angles with maybe a protractor at each of these corners and determine that all of these angles are congruent, then I can definitely say these lines are actually parallel.